Hello, everybody. Good evening and welcome to today's session. Can everybody hear me, please?
Yes, we can hear you.
Yes,
Good
I can
evening.
hear you. Good
Thank
evening.
you. So, good afternoon once again. Okay, so people are joining. Let's spare 1 minute or two before we take off fully. In the meantime, the table of content for today's class is okay. We'll be discussing for and while loops. So, underneath that, we'll discuss what is a loop, 3 types of loop, count control loops, for loops, drawing patterns programmatically, condition controlled loops, infinite loops under it, then collection controlled loops. So those are the 3 categories of loops that we will be discussing today. So before we delve into today's session proper, so yesterday I got 2 feedbacks. I'm still not quite happy that people are not taking time to at least provide feedback. It can only go 2 ways. It's either you have been absolutely satisfied with everything that we've been doing so far on this training, or you have some slight reservations on however much it is. So either way, there is something to give as feedback. So if it is positive, let us know. If it is negative, please give it to us. We can only improve from that. So yesterday I got 2 feedbacks, and I'll quickly relay the 2. The first of it was by somebody asking whether we can have the classes recorded and shared. So I explained to the person that the plan has always been to record it and upload it to YouTube. But due to some, I would say, lack of familiarity, which I think I've gotten over, the first class, I was able to record the first session. The second class, which was yesterday's class, I was able to record the second session. So it's not really fully coherent. Either ways, I'll try to make the ones I was able to record available. I think the second session yet from yesterday that I was able to record was particularly okay because it was clear. The first session from the first class was not quite clear, so I'm not sure it's going to be of much benefit. And I think everything I also said in that session can be gotten from the notebook I shared for the session. So the second session that I was able to record yesterday, I'll share it. I'll post it to YouTube. I'll try to do that today and share the link so everybody can access it. So, and I can also assure that this session is being recorded. The second feedback. So the second feedback I got was that yesterday's session was quite pacey, that it was too fast. That the person was like, maybe not everybody would be at that level of picking it up so fast. So I would like to get further feedback on that from other people. So I urge you to please, after today's class, take your time to give a feedback on all the classes we have taken so far. If you think we're moving too fast, then we'll find a way to adjust. And if it's also to find a way to explain why we're doing it like that, we'll do that. In the meantime, I'll still explain why I'm going this way. I said it yesterday that if you have to master anything programming, you have to be ready to put in the time and the effort. Whatever I'll be teaching you, or whatever anybody is even going to teach you in programming, the person can only scratch the surface of what is there to learn. The person can never teach you everything. In fact, you learn more on your own than you can be taught by anybody. So I think in conclusion, I urge everybody to take time to review the notebooks I'm sharing. I also shared 2 materials to the classroom stream, I think yesterday. So take your time to also go through those materials and pick more things. This class is just a 1-hour class daily. I can't teach you everything programming, even beginner part of programming. I can't teach everything in that time frame. So I have to move as quickly as possible to ensure that at least I introduce it to you. So I share the notebook to you. You get the opportunity to play around with it and also learn further from the notebook. I also share some materials which I expect that you go through and learn a thing or two from them. So I stated as well that I am open to answering questions, but I urge that if you have any questions, post it on the class stream. The WhatsApp I created yesterday, for those that have joined, is strictly for key information sharing. So we won't be entertaining questions there. The class stream is where you can ask your questions, and I can assure you, any question you ask, you're likely to get one of the participants of this training to answer it as well. So I urge everybody to practice very well. At the very least, dedicate 2 hours to practicing, at the very least. So that's not to say you shouldn't do more, but at the very least, 2 hours of your time daily to practice what you have learned and even more things. So we have 21 people that have joined the meeting so far. I think it is sizable to proceed with today's session. Okay, so for and while loops. To start with, what is a loop? So think of a loop as you holding a rope and folding it. So you folded the rope, that means you took one end of it and joined it to the other end of the rope. You've simply made a loop. Or you take one part of it and join it to the other part of it. Then you have created a loop. So a loop in programming is, I'm reading from this place, is a sequence of statements which is specified once, but which can be carried out in several times in succession. So repetition, basically, repeating a particular action a number of times is what loop is about. So 3 types of loop. So our focus in this class is on just 3 types. Not to say that there are no other variants of it, but other variants will likely fall under these 3 categories. So the first is count-controlled loops. The second is condition-controlled loops. And the third is collection-controlled loops. So we'll expatiate further on what each of them means. So count-controlled loops. Basically, we'll be talking about 4 loops here. 4 loops. Okay, so a for loop is used for implementing code repeatedly a certain number of times. So you have a code block and you want to carry out the action in that code block a number of times, a specific number of times. So that is what a for loop is used for, especially a count-controlled for loop. Okay, so this is the syntax. For I, this I, think of it as anything, any string, or sorry, any variable. So it's basically assigning a variable on the fly. I remember yesterday we mentioned how variable declaration in Python is dynamic. You don't have to clearly or separately declare a variable before you assign value to it. So here we are declaring it and the value gets assigned on the fly. So for I in range n, do. So think of this do as a code block. It could be one line and it could be several lines. Okay, so to see how this works, let us imagine a troubling child who just offended the mom, for which the mom requested the child to declare, I will not do that again, 10 times to be forgiven. Okay, so this is count control loop in action. So there is a count. The child is given a count, the number of times that, okay, I want this done 10 times. But you'd agree that the thing you're doing 10 times is repeated, is the same. So this is a typical illustration of a count controlled for loop. So let's execute this. We have for I in range 10. Remember, the child is requested to do it 10 times. So print, I will not do that again. So we execute this code, and there it goes, 10. It came out too fast, and you probably have to count to be sure it is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But there's a better way to actually do the counting. So as we are looping through, let's put the counter here. So there it goes. Although it starts from 0, but this is an agreement with what I said yesterday, that Python and indeed most programming languages are 0 indexed. That means any count operation starts from 0 rather than 1. So here, for instance, if I wanted it to start from here, from 1 rather than 0, I would simply add 1 to each value of I. So what is happening here is this for loop. So it takes this range, it executes this range function first, and the range function creates a virtual list of 0 to 9. 10 is not inclusive, still agreeing to the fact that it is 0 indexed, and you don't count, the last item is not usually of essence. So it creates a virtual list of 0 to 9, and this I here, this variable I, gets assigned to each of the items in that order from 0 to 9. So that is what basically happens in this loop. So think of it as creating this virtual loop. This virtual list 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first time it picks 0 and it comes and executes this, print 0 plus 1. Let me run it. So print 0 plus 1, which is 1. Then these other operations which I've explained yesterday with it. So, and it goes the second time, picks 1, comes and executes this do function, print in this case, 1 plus 1, 2. And that's what gives us the second line. And we have it as it is. So to make it a little bit interesting, I added a bit of timing to it to slow down the output. So this will make you see how it prints out one after the other. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Voila. So the next example we'll be considering. So this one requires you to provide an input. So it creates a virtual list of 0 to 2 here, 0, 1, and 2, and it takes one of it, each of it one at a time. So now what happens here is this line of code gets an input from you. So let me execute it. So it tells me here, enter a number. So it tells me, enter a number. Any number, it doesn't specify any number, right? So I enter 5. Then it gives me an output. The square of your number is 25. And it asks me to enter another number. Remember, I've not told it to do anything. It just told me to enter. I ran it once, and it has been executing. So I enter another number, 3. It tells me the square of 3 is 9. I enter 8. 64. I enter 12. Okay, so it is done running the loop. So after having exhausted the items in this virtual list of 0 to 2, it ran it 3 times in agreement to the 3 items in the virtual list is created. So, and it gave me the output. And at the end of it, it told me it's done running the loop. So here is another example. Example 3, summing the first n integers. So think of this as series. In O-level secondary school mathematics, you learn about sequences and series. So think of these as series. How to sum the first n numbers, for instance, or the first n positive numbers, first n even numbers. The n could be any number. So here, we're creating n as 50. So let our n be 50. Although there's an option for you to also enter your inputs. If you don't want to go with the n that has been declared, you could make use of this. So let's see what happens here. It tells me to enter an integer. So I enter 10. You have entered 10 as n. The sum of the first 10 integers is 55. And that is it. So, but if for any reason, if I were to comment this code out to make use of the 50 and print out so the sum of the first 50 integers is 1,275. If you want to confirm that, if you know the formula for series for first n terms of a series, I think it's a plus n over the length of the size of the series. So you easily get it. Did I get it correctly? No. Okay, n over 2a plus l. Yeah. So n over 2a plus l. In this case, our n is 50 divided by 2. Excuse me. So our n is 50 divided by 2 is 25. So 25 times a plus l, 50 plus 1, right? Our a is 1, our n is 50. So 50 plus 1 is 51. So when you multiply 51 and 25, you get the answer on the screen. So I want to ask if everybody is following along.
Yes.
Okay.
Yes.
Yes.
Okay, so let me explain this, although the explanation is there anytime you're reviewing it. The reason I added 1 here, remember, if I were to just leave here, let me just use a very simple, sorry, wrong. Sorry. Sorry, I'm trying to fix an error here. String object. Okay, so I'll restart my runtime. It appears to be misbehaving. Okay, so it's fine now. So you could be faced with this situation I just got now. A working code was giving error. So I quickly figured that the kernel was misbehaving. So that's why I restarted it. Okay, so let me enter number 5. Okay, a simpler number 3. So to sum the first 3 numbers, we have 0 plus 1 plus 2 plus 3, right? So 1 plus 2 plus 3 is 6. So if I had not included n plus 1 in this line, I'd have gotten 3, which would be incorrect. So that was the reason why I included 1 here. So going forward, so let's look at this now. We've created a list here, class list. This is another example. So we want to loop through and print out each of the items in this list. So we still use that. Remember, the number of items in this list is 4. And for that reason, we pass in 4 as the argument for this range function. That means create a virtual list and start from 0, 1, 2, and stop at 3. So now print, let's see, 1, Olu, 2, Adamu, 3, Kofo, 4, Ebi. So I also did the trick of adding 1 here because I don't want my counting here to start from 0. So and I used, I concatenated an asterisk. I could have concatenated a full stop. It could have been anything. So now, let's quickly check a range function. We'll be using the range function, but we've not really explained how it works, at least not adequately. So a range function is declared as this. This is the syntax, range. Then you have the start argument, separated with comma, the stop argument, which is optional. As you have seen so far, I've only passed in 1 argument, which is just a single number as the argument for this range function. So, and that's the stop. Sorry, the start is the optional argument. I beg your pardon. So the start is the optional argument. The stop is the most important one, which must be passed. Then the step is how many steps do you want it to take each time it runs. So by default, the step is 0. I mean, it's 1, sorry. And by default, the start is also 0. As you have seen from the previous examples we have been running so far. Pass in a single argument and it runs and increments by 1 at every step, starting from 0. So that's because this start is defaulted to 0 and this step is defaulted to 1. But you can change how the 2 of them work. So here now we're saying print all even numbers between 2 even numbers. So think of 2 even numbers, say 2 and 10. So between 2 and 10, print all the even numbers between 2 and 10. Not with 10 not inclusive, maybe 10 not in between, right in between, but 2 inclusive. Okay, so here we declared our n as the start and our m as the end. So here we're saying print between 4 and 70. So let me make it 4 and 10 so we can relate well. So for I in range starts from 4, n on number 10. Take 2 steps each time you run. Then for every time you run, print the number you have the number you have taken at that run, print it out and end it with a comma. Okay, so let's see. And there it is. It prints 468. But we're not yet summing it, right? So if we wanted to sum it, we'll create a sum. We'll create a sum and default it to 0. So we come here and say for every time you pick a number, do the following: sum it, take the current sum. Remember, I've declared sum as 0. So this current sum plus the number you have picked. Remember, this variable is picking the numbers. So take the current sum plus that number you have picked at that time. So here we can as well, at the very end, print the sum is so 468. The sum is 15. So something is obviously wrong. It hasn't printed correctly. Okay, so let me quickly check. We're almost running out of time for this first session. Let me quickly check and fix the problem here. Four, 6, 8. Okay, so I didn't put underscore. All right, so that's it. So at this juncture, we will end this class and resume back at 5:30. Thank you.
Thank you.
Thank you.